A second type of chemical reaction is called decomposition, and you can see from the picture you're going to have a single compound and it's going to be broken down into individual elements, or it could be broken down into an element and a compound, but we have to have at least two products. For decomposition, it's a chemical change. You are taking your beginning substance, your beginning reactant, and you are chemically altering it into two or more smaller products. There is only one reactant. If anything, decomposition and synthesis are kind of reverse reactions of each other. So decomposition only has the one reactant, and sometimes the products can be difficult to try and distinguish what they what they'll be. In class we will be working on a few different types of decomposition reactions and just what the products would be if certain polyatomic ions are present. So we'll be working more with this one outside of this video. If we would have a binary compound, those are probably the easiest. Binary again means two, so if we just have the two elements put together into this compound, then they are going to break apart into their individual elements, in this case mercury and oxygen. Don't forget, oxygen is diatomic, that's why the O2 is there when it's by itself. Most of these decomposition reactions do need some type of energy. Most things are not just going to start to break down on their own. They're going to need some type of energy source, whether that's heat, light, or electricity, to decompose. So if we move straight away into a practice problem, most of these are going to be very simple ones. So binary, we're looking at just two elements, and so those are always going to break down into their individual elements. In this case, water. In order for water to actually break apart, which we can do, we can chemically separate the oxygen and the hydrogen, but they won't separate on their own, so they do need this electricity here in order to do that. They're going to break down into their individual elements. So we know that we're going to have hydrogen. Hydrogen's a diatomic, and so is oxygen. So H2 and O2. And from there it's just a matter of balancing your chemical reaction. So we have our two hydrogens, those are good already, but oxygen is not. So we want to go to the side that's lower, in this case the O over here by itself, and so we need two of those. And of course that does take care of the oxygens, but it messes up our hydrogens in the process. So now we have four hydrogens, and we need to come back to our product side, put a 2 out in front there, and we'll have four hydrogens there. So that would be an example of a decomposition reaction. We could also take a look at the hydroiodic acid here, HI, and it's binary. We have just the two elements, and so if we break it down into their individual elements, we have hydrogen, which again is diatomic, and iodine is 2. Iodine's one of our 7. So if we break them apart into their individual elements, all we need to do at this point is just balance it, and we can do that by putting a 2 out in front of the HI, and that takes care of the hydrogen and the iodine at the same time. And then thirdly, we have this one. Now this one, the product's already been given to you, and it's binary. We just have hydrogen and nitrogen. So the original formula for this one, if you think about hydrogen is a +1 charge, and nitrogen is a -3. This one had to be H3N. So you would have hydronitric acid, and this one is not balanced, so we do need to balance it. And if you could start with hydrogens if you want. Hydrogens are a little messy because you have an odd 3 on this side with an even, and so there's nothing that you can do to just one of them. You're going to have to change both of them. I usually save hydrogen for last. You could start with that if you wanted to, but nitrogen is a pretty easy fix, so I'm going to go ahead and I'm going to change the nitrogen first, and then that will hopefully make the hydrogen easier to balance. We'll see what we should have. So if we have 2 nitrogens on our product side, we can fix that by putting a 2 out in front of our hydronitric acid, and that gives us 6 hydrogens, and so we would need to put a 3 on our product side with hydrogen to make it 6. So whenever you have an odd-even situation like we did with the hydrogen, you're going to have to change them both, and the easiest thing to do is find the number that they, the least common denominator the number that they would both go into, which would be 6, and so we would want to make 6 hydrogens on both sides. So that would be a 2 with the odd one and then a 3 with the even one. So that's the way you would take care of an odd-even situation. That happens occasionally when you're balancing. So just a quick review of decomposition. You are taking, a compound and breaking it apart into 2 elements, or it could be a compound and an element, but you're breaking it apart into 2 items at least. It could be 3, but usually 2. The reactants are normally just a single binary compound. All of our examples in today's video were all binary, but it doesn't have to be. Sometimes it is a much larger compound. If there's a polyatomic ion in it, then you could get various different products. And the product is either going to be 2 elements like we had in all of ours, or it could be 2 elements in a compound, or 2 compounds with an element, or a compound and an element. So there's definitely a lot of variety. We will be going through a few different predicting the products of decomposition. We're going to be going through a few examples. If there's a certain polyatomic ion involved, we can kind of help predict what the reactants will be, what the products will be a little easier. So we'll be doing some more work with decomposition in class.